What if we could use the batteries in these cars and turn them into a giant battery for the power grid? Most people's cars are parked 96% of the time. The real question is going to be, what does this car do when I'm not driving it? If the frequency goes outside of a really narrow band, then you get a huge power blackout, and you get this cascading blackout, and then the whole grid collapses. Imagine if you could power your house because you have a Ford F-150. Sooner or later, the garage of the American consumer, they're going to see it as the power plant of their house. Every hour that your vehicle's plugged into your charger and it's not doing anything, you could be generating passive revenue. I really think we're going to see EVs as a fundamental energy infrastructure rather than transportation.
On today's episode of Decarbonizers, I'm joined by Idrees Rivas, CEO of Tether EV, a company focused on turning electric vehicles into intelligent energy assets through vehicle-to-grid technology and decentralized energy systems. We discuss how EVs could help stabilize the grid, the rise of virtual power plants, and how AI and energy markets are shaping the future of clean energy infrastructure. This is Decarbonizers. Thank you so much for being on the Decarbonizers podcast.
Thank you so much for having me.
Excellent.
It's a pleasure to be here.
So before we get started, I actually did want to learn about your background. What originally pulled you into the whole energy space?
Oh, that's a good question. I mean, I've always known I wanted to be an engineer for a long time. I think since I was 9 or 8, I used to say I wanted to be an aerospace engineer and I wanted to help build the rocket that took people to Mars. But at the same time, I was always very passionate about nature. And anyway, when I was choosing my major for college, the space shuttle program had just been canceled. There was no SpaceX yet. So I chose to get into electrical engineering. I wanted to bring renewable energies and connect them to the power grid. And basically from then on, my goal was to get as much solar and wind connected to the grid as possible. And that's kind of how it started.
So when did the idea of Tether first click?
That it took a while. I think Tether is very interesting. It's kind of the sum of all my little pieces of my life in both academia and professional life. So I studied electrical engineering, power systems, particularly integration of renewables into the power grid. So that was always kind of my focus. And my first job was actually working for the Florida Power Grid, FPNL. And, I was a guy that you called when the power went out and you needed to yell at someone. So I very quickly learned what's failing on the power grid, what's really not, what are the common points of failure, what's the areas of, where the grid is just not working as it should. Once I graduated, I went to work for General Electric. I started as a gas turbine control system engineer. And essentially, the system they put me to work on while I was there for the few months I was the governor droop control, which is essentially the automatic control system that makes gas turbines increase or decrease their power to maintain a stable grid. And I thought that was really, really cool. It's a really cool system. All of these gas turbines all these turbines around the world, they all know exactly how much power to increase or decrease to maintain a stable grid without any communication system between them. So I thought it was fascinating. Then I jumped to the solar division of General Electric, and now I was on the other side. So now I was trying to connect solar panels to the power grid. I had to go and interface with the grid operators, and it's a pain in the butt, to say the least. There's always, this line can't handle this much power during certain times or whatever. There's this instability on voltage. So I was kind of getting all these pieces of the puzzle. Then I moved to Sweden to do my master's, and I learned about the way the electricity markets worked there. I graduated and started working for a company called Northvolt, which was at the time Europe's largest startup and Europe's answer to China in terms of battery manufacturing. And I was working with a battery system that basically replaces diesel generators and stuff. So there you had all the pieces, which was, okay, the grid is failing in these sense. Here's how we solve it today with gas turbines. Here's the problem with renewables when integrating to the power grid. There's a lack of storage. It passes the capacity of lines at certain points. And battery storage is
Yeah.
great, but it's still very expensive and it's not being deployed. So that led to the question of, okay, could we do this? I mean, we need more energy storage, but energy storage is expensive, and we don't want to do grid balancing with gas turbines because it's bad for the environment. It's expensive, right? So what could we do this for? And essentially, I remember a particular moment when I was working at GE that it just kind of clicked, like a few years later, which was I was at the factory in Schenectady, New York, and there was this shift change at the factory, and there were all of these pickup trucks underneath these solar panels that we had installed, and there was one EV, like this tiny little EV, and I remember thinking, when all these cars are electric
Yeah.
vehicles, it's going to be a giant battery underneath these solar panels. And then it kind of clicked. And I remember that. And I was like, oh, we have so many EVs. We're going to have so many EVs in Europe. They're parked so long. Their batteries are gigantic. So what if we could use the batteries in these cars and turn them into a giant battery for the power grid? And that's kind of
All
the
right. Very
idea for
fascinating.
Tether.
Yeah. Most people think of their EVs mostly as like transportation, but Tether seems to think of them as like energy infrastructure, which I find very interesting. I would have like never thought of that, but in a lot of
Absolutely.
ways it does make sense because it's a giant battery.
Yeah, and here's a really interesting thing about your vehicles, right? Um, Most people's cars are parked
Yeah.
96% of the time. They're unused, right? We think about the cars when they're taking us from point A to point B, but that's 4% of the time
Right.
of the vehicle's use. The other 96%, it's sitting there. In the case of a gas car, well, it's not really doing anything. But if you have a gigantic battery that's at your house or at your office or whatever, I really think that the paradigm shift is going to come in the next few years where people are not going to be asking, okay, what does this car do when I'm driving it? But actually, the real question is going to be, what does this car do when I'm not driving it? What is it doing for me? Is it generating revenue for me? Is it helping balance the grid? Is it storing the solar for my household? So I think the value proposition of the vehicle is going to shift to what does it do as an energy infrastructure or as a giant battery? And I think this is the
Got it.
beginning of
So
that
in
transition.
Europe, all right. So I'll tell you over here in like the United States, we have a bunch of utility companies. In California, in particular, they have investor-owned utilities such as Southern California Edison,
Mhm.
PG&E, as well as San Diego Gas and Electric. And pretty much when you feed power back into the grid from a solar system, they don't really give you credit for it anymore. And they also have time of use rates. So from 4 to 9 p.m., that's when power is the most expensive. However, they have something called like virtual power plant, where there are going to be grid events where if you have a battery on your home, or let's say in this case an EV, you can actually get a decent cost per kilowatt hour when you feed it back into the grid. Is that similar to what's available in Europe?
Exactly. I mean, a virtual power plant is a bunch of distributed
Right.
assets that are able to coordinate and feed in power or stop consuming power or whatever. And that's essentially what is being done here, but it's a little bit different. So I forget the exact mechanisms in California, but I think they pay you per kilowatt hour. So like how much you inject or not into the grid. Here it's a much more complex and dynamic mechanism, which is basically grid balancing, and you have different stages of grid balancing: primary, reserve, secondary, tertiary. And really the only difference between them is like how fast and how dynamic the activations are. But what is happening here is the grid is paying participants to actively manage the frequency of the power grid. Okay, now the frequency of the power grid is very interesting. This is going back to my GE days of me thinking it's a really cool idea. The frequency of the power grid is a real-time instantaneous measure of the balance between power going in and power going out of the power network. If the power going in is higher than the power going out, the frequency starts to go up. And vice versa. If the more power is being drawn than is being generated, the frequency starts to go down. Now, if the frequency goes outside of a really narrow band, which is 60 hertz in the US and 50 in Europe, then you get a huge
Oh,
power
wow.
blackout,
Okay.
like what happened in Spain, right? Every single generator and everything that's connected to the grid starts to see this decreasing frequency, and they say, "Uh-oh, something's happening. I'm gonna disconnect because this is gonna damage my system." So one by one, you start to get power plants and loads that start disconnecting, and you get this cascading blackout, and then the whole grid collapses. So that is the worst case scenario. It's happened in the U.S. before. I think like 2003, the whole Northeast was
I was
without
actually
power.
in New
It
York
just
City when that
happened
happened.
in Europe. Exactly. So that's a cascading blackout. Same thing happened in Spain and Portugal and France. About a year back, I was here, and it was kind of crazy, like everything without power. And what Europe does right now is it has these liberalized open markets where anyone that meets the technical criteria that the grid determines can participate and either increase or decrease their power consumption or production to maintain a stable grid. So what we do at Tether is essentially, how does it work right now for most of the cases is, let's say there's not enough power being generated at a moment's notice. So a gas turbine or a hydro turbine, what they would do is they would increase their power production to fill in that gap. But what we say is, well, hold on a second. What if we could decrease our consumption to eliminate that gap, right? So rather than generators having to increase or decrease their production to meet demand, what if demand could increase or decrease to meet the supply? And the benefit here is an electric vehicle or any of these power electronics, they don't have
Right.
any moving parts. There's no spinning generator that has momentum or inertia that has, it takes a little bit of time to increase or decrease. And there's no gas or fuel or anything that's an opportunity cost or a cost of operation. It's an asset that is charging, can instantly stop or start charging to meet that. And essentially, we get active grid balancing reserves that are able to do the same job as gas turbines or other generators without any of the capital expenditure that goes into those generators, without any of the fuel that goes into those generators, without any of the, hundreds of people that are running that plant. So you get really this gigantic
Right.
virtual power plant that does dynamic load balancing, across the markets, depending on the time resolution, how fast they need to activate, which is
That's
very
really
cool.
interesting. Are there actually enough EVs that can do that right now in Europe?
Yeah, it really
Yeah.
depends on which market and where you are. So, I was just in Oslo last week. I don't know if you know this, but uh, Norway is the number one country in the world as
They have
far
like
as
90%
EV
adoption over there, correct?
penetration goes. Well, it's as of 2025, or sorry, 2026, it's 100% of vehicles that are
Oh,
sold have to
wow.
be electric. So there's no more gas vehicles as far as I know. And maybe they push back the deadline a little bit, but as far as I know, there's no vehicles that can be sold now on a consumer market that are not electric. Um, so it's 100%. From now on, if you want to buy a car in
Okay.
Norway, it has to be electric. And so the Nordics are kind of leading this. Sweden and Denmark, Finland are close behind, and that's why we're there. So we're in the Nordics operating because they're just a little bit ahead of the curve when it comes to
Okay.
percentage of EVs sold. But just to give you a number on the number of EVs in Europe, it's projected by 2035 there'll be 130
Okay.
million
So
electric
that's
vehicles in Europe.
one giant
So
big battery right there, right?
yeah, each vehicle, when they're plugged in at a typical residential charger, they consume about 3 to 5 times the power of an average
That's right.
household. So if you think about it that way, each EV is 3 to 5 houses. 130 million EVs is a lot of power. So that's the That's the whole premise here. Granted, there's a lot of markets where EVs are not that prevalent yet. It's all about, how much can you get
Mm-hmm.
at once. So it doesn't matter if you have a ton of EVs, if they're all if it's a very small percentage of the pool of vehicles, let's say, it's it's a little bit unpredictable. But that's why we're targeting high penetration countries, because essentially you can say, okay, we have these chargers on the street, and we're pretty certain that there's going to be
Right.
vehicles plugged into these chargers at some moment in time. And so we can target those chargers or the vehicles themselves and modulate their power consumption to create a giant
Awesome.
battery on
So
wheels.
I have a quick question. When it comes to vehicle to grid, like the actual vehicle feeding power into the grid, are there any concerns related to battery degradation? And if so, are the OEMs, the manufacturers of these vehicles, okay with these EVs doing V2G?
That's a very good question. And let me just clarify. Right now, most cars and most chargers
Okay.
cannot do V2G. They can only charge and stop charging. They cannot discharge. There's no electrons flowing out of the battery into the grid. So we are doing that right now because that's the vast majority of the fleet connected to our system is unidirectional. Um, and so in that case, there's no additional cycles. In fact, it's probably better for the battery of the car.
Right.
It's kind of like your iPhone, right? Like your iPhone, you plug it in at night, it doesn't charge the full immediately. It kind of learns when you're going to wake up, and it delays the charging to a later point in the night so that the battery isn't as full. So that's kind of what we're doing now. We're delaying and shifting the schedule and the charging of cars to match grid conditions. And that's, in short, there's no additional cycles. It's typically better for the battery. When it comes to V2G, bidirectional, yes, of course, there's concerns about battery longevity and how many cycles you're gonna be putting onto this car. Um, the same as any stationary storage, I would say. So the key there is you want to be very, very sure that the rate of speed and the way that you're operating those vehicles and those batteries, they're within a certain safety range, so you minimize the damage. And of course, you want to minimize. You don't want to be charging,
Right.
discharging, charging, discharging. You have to you have to put a limit on that. You have to also calculate, like, is it worth it? Right? Is the cost, is my capital, is the loss of value of my battery greater than the money I'm making on the market for that cycle? So you want to put these kind of constraints into V2G. Otherwise, you're gonna go crazy. Um, so yeah, there are those concerns. I think we've seen plenty of studies that show that if you do vehicle to grid with optimization for battery degradation, you're actually able to reduce battery degradation and still provide value for the power grid. But it certainly is a lot trickier than the V1G case, which is what we're doing now. Um, so yeah, going to just to close the question on vehicle manufacturers and their warranties. I think they're definitely looking into this. I mean, we were speaking to a bunch of OEMs, and that's one of their questions. Like, okay, what are you going to do to my battery? Is this going to void? Is this going to void my
Right.
the amount of range or lifespan that we have on it? So they're a bit cautious, but I think it's going to be something that every car is going to have in the next few years, especially with the advent of Chinese
Right.
EVs kind of coming around the world. They're very aggressive with some of these technologies. And one more thing, not every battery in an EV is the same. So especially with the Chinese cars, we're seeing that they have LFP batteries rather than NMC. And LFP batteries have much more, they're a lot less sensitive to cycles. They last a lot
The
longer. They
LFP
don't degrade
batteries,
as much.
correct?
So I think it's a combination of
Okay,
factors.
got it.
Yeah.
Very interesting.
Mhm.
All right. So, yeah, I mean, I'll tell you one thing. Like, I have a Model Y Tesla, and I think it was really like that first like year or two, I noticed like some degradation, but I've had the car now for like 5 years, and it seems very resilient. I've charged it, discharged it. I plug it into superchargers when I drive to Houston. They seem like they're getting more resilient, the battery chemistry or the actual battery itself.
Yeah, I mean, battery technology has gone. It's accelerating. I mean, the development is accelerating at such a rapid pace. There's a battery from like that comes out right now has so many more, much more longevity and so
Right.
many more features compared to batteries that came out. Like if you compare what that the old Nissan Leaf to what's coming out of a BYD,
Yeah, of
it's night
course.
and day,
A lot
right?
more range too.
And a lot more range. And funny enough, I mean, of course, the battery is degrading from day one. But what they do with an EV is they put like
Hmm.
a safety margin, so you don't notice any degradation for the first few years. So essentially, your the battery capacity, let's say, is never actually when it shows you 100% charged, it's not actually 100% charged. It's
Oh,
maybe
interesting.
80 or 85%. And so your battery actually had more capacity. And as that, let's say, as your vehicle ages and your battery ages, the max kilowatt the storage capacity of your battery is going to decrease. So eventually, after a few years of time, you're going to notice that yeah, you're starting to lose range, because what was marked as 100% charged is now actually the 100% or lower. As the if you imagine an imaginary line of at the top that's capping how much the battery is actually able to hold. And okay, I'm doing a
Oh,
really
good.
bad job explaining this without a visual guide. But essentially, the ceiling starts to drop, and eventually you start to notice that degradation. But at the first few years, you're never actually reaching the full capacity of your battery. So I think people overestimate the degradation of their vehicles' batteries today. They have nightmares, I think, still from like
Right.
2016 or something. But these vehicles, their batteries can last, so long now before you even notice degradation, because they even have a safety margin built in. So, and if you have LFP batteries, they last even
Yeah.
longer. And yeah,
One
it
thing
really
that we're
varies.
seeing with like the bigger like batteries over here, like there's like the Ford F-150 Lightning as well as the Tesla Cybertruck. They're really
Mhm,
promoting those vehicles with a vehicle to grid charger. And I mean, it's a
mhm.
massive size battery. I actually have a stationary storage battery on my house, a Tesla Powerwall, but that's only 13 point,
Yeah.
excuse me, but that's only 13.5 kilowatt hours. So small battery compared to what the EV has.
No, I mean, exactly to your point. I don't know. I can't remember the size of the Ford F-150 battery. I mean, that thing is huge. I mean, the truck
Right.
itself is gigantic. So for Europeans that are listening, uh, cars here are smaller than in the
Yeah.
US
Right.
significantly. um, and that size, obviously, bigger battery. Um, I've always like I said at the beginning of the show, I think people will be asking of their EVs, what does this thing do when I'm not using it? And to your point, why would you have a Tesla Powerwall installed in your house if you have a giant pickup truck that has a battery that's 10 or 20 times the
Correct.
size of that Powerwall, and it's plugged in and it's available, right? So you only need your battery when you're home, and you're only home when your car is home.
That's a
So,
really good point.
uh, right? So, yeah, for example, like the Ford F-150, I think it's a fascinating idea. Imagine that you are a construction worker and you pull up with your giant pickup truck, and then you're like, I need to power these lights or this equipment at my construction site. And rather than bringing a diesel generator or something, you just plug them in straight to an outlet on your truck, and it's a portable battery. Or you have your Ford F-150 and the power goes out like it does in
Right.
Texas all the time, and There was like that
Yep.
giant winter freeze a few years ago, right? Imagine if you could power your house because you have a Ford F-150 and you're like, yeah, I have a giant battery that can last for 2 or 3 days. That's what we're talking about here. Um, so yeah, I think, of course, like having storage at your house, especially if you have solar, it makes a lot of sense. You're capturing the excess solar when your vehicle is in home, maybe you're at work. But sooner or later, the garage of the American consumer, they're going to see it as the
Oh,
power plant
wow.
of their house. This is my power plant room, and it's because it's where your cars are parked. And so imagine all the things you could do. Your car could be not only absorbing solar from your roof, and not only could it be, your backup power plant when the lights go out. It could be trading on the electricity markets and like selling electricity when it's high and buying it when it's cheap. So you're generating passive income from your vehicle, right? And maybe it pays off its own
Yeah,
like
of course.
maintenance. Who knows? There's so many possibilities, right? So I think that's where we're moving. The technology is maturing. Unfortunately, right now it's a race to the bottom in terms of price. Vehicles are very expensive for most people, and long gone are the days of a car like
Right.
being 16K or something. The average price of a vehicle in the US right now is like
Yep.
50 something $1,000, which is very unaffordable for most people. And it's part of the big reason that EVs were struggling at the beginning because they were just more expensive than their ICE counterparts. But we're finally seeing that we're crossing that threshold of price parity or very close to it. Europe and BYD and some other brands are, they're launching vehicles that are in the
Yep.
20,000 range, EVs, right? City cars. So it comes to a point where soon price won't be the most important factor because everyone will be able to match, a similar price point if they want to. It'll be more about, okay, what features am I getting? What are the things that my car is able to provide? Because yeah, the range will become irrelevant, right? Range anxiety was a huge thing. Oh, I want a car that's so big because I want it to be able to take me from here to here. But when every car is meeting that requirement and when the costs are not as big a factor, then it's going to be about the features. And I think that's what we're seeing in non-Western cars is like, I don't know if you've ever been in a Chinese car. They
Oh,
have
wow.
like
I haven't been in a
karaoke,
Chinese car.
they
That
have
sounds
like
fun.
lights and microphones and they have like all these crazy features because it's now about differentiation in that
Okay, very
sense.
cool. Wow.
So
I
it's
was going to ask,
quite
like, in terms of
interesting.
like the net benefit for the consumer, like if they enroll or if they're using Tether, what do you think the average EV owner can benefit per year from doing this V2G program?
Very difficult question to answer because it varies significantly from market to market. Um, I can give you the Swedish answer, which I don't know if that's as interesting to your American viewers or listeners, but um, it can range from 1 to 3 euros per charge cycle,
Okay.
with your car. So that really depends on how long your vehicle is parked, um, what the prices of the electricity market are at the time that it's parked. So if you're really lucky, I mean, it can be much higher than that. That's the average. That's the range I'm giving. But we see when there's about to be a power outage,
Yep.
the prices spike because they need people to consume more or less. So if you're charging at that time and you stop charging, you're going to be paid a lot. And there might be moments when there's a lot of wind and there's or excess power. There's people aren't consuming as much energy. It might be really low, but on average, what we say is 1 to 3 euros per charge. Is So if you charge 100 times a year, you know, it's $100 to $300, which it adds up. It becomes it's a nice benefit, I would say. Maybe it's not going to make or break your bank account, but over time, it's something that adds up, and
Yeah, well, one thing I
well,
was
it's
also
free
thinking about
basically.
is just kind of like the societal benefit. Maybe a lot of EV owners will be happy to know that, hey, because I have an EV and, I'm able to put power back into the grid, it prevented a blackout from happening for my whole city.
Oh, certainly. Yeah, no, I mean, and there's a lot of things there. So, first of all, the numbers I gave, this is for balancing,
Right.
like just straight up balancing revenues. I didn't talk about energy arbitrage. So, hey, how much am I saving, right? Because I'm charging when the electricity is lower. So, if I don't charge during the peak moments and I charge at a moment where electricity is cheaper, then not only am I generating revenue, but I'm also not paying as much for my electricity. So the delta becomes bigger in terms of the benefit. But you're certainly right, and this is really hard to quantify. Is how much are EV prices or these kind of reserve prices driving down the cost of the electricity that you're buying on a day to day? So just to give listeners a perspective, of course, you pay per kilowatt hour. But there's a bunch of other factors and fees
Right.
that are hidden in those numbers of what you're actually paying, right? So the grid, at least in Europe, and I'm pretty sure like in the United States as well, they have to have a certain amount of reserve capacity available at every hour of the day by law in case there's going to be a grid event. So typically that's known as the N1 criterion. So what happens if my largest power plant in the area goes down? Is my grid still able to operate? In the case of Sweden, for example, it's a giant nuclear power plant. So they have to have, I think, 526 megawatts of reserve capacity available every hour, every day in the primary frequency market. So the price that you're paying for a kilowatt hour isn't just the unit of energy that was generated, but is the total factor of what was the price of the most expensive unit that had to be operating on the market at that time to ensure that there was that much capacity available. So you're paying the price of the most expensive generator that's available during that time. And just to give you an idea, in Sweden, the prices of primary frequency reserves in 2023, the average was around 40 to 60 euros per megawatt per hour. The price today is like 3 euros per megawatt per hour. And the reason that happened is because there was such an excess of batteries and other demand side resources that came into the market that the price of that fell significantly. And ultimately that ends up reflected on the energy bill of every single person in that nation, even if they don't
Wow.
know it directly, right? So very hard to quantify, but it does, of course, have big implications for our society if we are able to use resources that are already available, that are already paid for, that don't have this
Yeah, of
geopolitical
course.
risk and or supply shocks or whatever. That trickles down. It has to, right? So especially if users start doing dynamic energy contracts with their energy retailers. So, for example, in Sweden, 50% of people now, they don't have a fixed fee or a fixed price per kilowatt hour. They have a variable price that follows the spot market on a day to day. So that means that you can optimize and choose when to charge and when the electricity is going to be coming to pay a lot less price. So all these things kind of feed into each other, even though it's really hard to say, okay, my EVs drove the price down by this much. You will ultimately feel it, and that's the whole point of these demand side resources. It's cheaper, it's greener, and it's more efficient, and ultimately that's going to be
Yeah, that's
reflected in your
amazing.
energy bill.
Awesome. So one thing I did want to talk to you is about kind of like the data you guys analyze. So you guys don't necessarily analyze charging behavior. You guys analyze driving behavior. Can you both? Okay.
Well, both. It depends on what asset we're connected to. So if we are connected to a charger, then all we can see
Right.
is when is a vehicle plugged into this charger, when is it being used, and that can be a residential charger, which most likely correlates to the same user, Or it could be a public charger, and that's multiple users coming in, and who
Right.
knows who it is on the other side of the plug. Or it could be the vehicle itself. And the vehicle itself, of course, you have a lot more data because the vehicle is telling you where it is and what's the state of charge, what's the size of the battery, blah, 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 blah. Right? So
Sure.
just want to
And
clarify.
were you surprised with anything you analyzed from this data? Did you notice any interesting trends when it came to driver data or charging data that surprised you?
Um, yeah. People come in
Yeah.
at really strange times. No, there's always like this one, like these drivers that drive us insane, which is, what the hell are you doing at 3:30 in the morning, leaving and coming? Strange stuff. No, but in all seriousness, people are very predictable most of the time. I
Okay.
mean, on
Right.
a large scale. Obviously, you have outliers. There's particular days where you're like, what the hell is this person doing? Who knows? But for the most part, people follow the same patterns. They come in at the same time, they leave at the same time. Most of the time, they drive the exact same route from work to home and vice versa. So, yes, there's a lot of uncertainty with EVs. They move and people have their own lives and their own schedule. But en masse, as you get more volume, it's a relatively predictable
Yeah.
resource, kind of
I
like wind
really
or
plug in my
solar.
car at like the same time. And anytime I have like excess solar, I like go down to my garage and plug in my car. Yeah.
Plug it in. Well, ultimately, so here's the thing that's really interesting, and let me drive this point across. So the grid is not paying you, or balancing the grid is not just the action of balancing the grid; it's the availability to balance the grid. So what does that mean? Let's say that I have a generator. I'm a gas turbine. I'm plugged into the grid. I'm being paid every single hour for every megawatt that I have available to balance the grid, even if it wasn't needed. So if I have a generator that could be generating 10 megawatts and I'm just sitting there, my generator is spinning, but it's not generating any power. I'm standing by. I'm being paid every hour for those 10 megawatts that I could generate. It's the same thing for consumption. So if if I'm able to consume more or I'm able to consume less, I could be paid for that every hour that I'm available to do so. So what I mean is, you could plug in your car and tell it not to charge, but tell it that it could charge if the grid has excess power that it needs to get rid of. So every hour that your vehicle's plugged into your charger and it's not doing anything, you could be generating passive revenue simply for having it available for all those hours of the day. So, and that's really important because right now, most people only charge their car
Mhm.
every 2 to 3 days, right? Actually, the average is like 3 to 5. So you get home or you get to your office, you don't plug it in every day. I mean, maybe you do, but a lot of people don't, right? Um, and I want to live in a world where we don't do that, where we get home and we plug it in, even if you don't need to charge, because you're basically saying my vehicle could charge if need be. I could help the grid if need be. I'm getting paid if, regardless of whether it happens or not. Or vice versa. Every hour that I'm plugged in and charging, the fact that it could slow or stop my charging means that I'm also getting paid. So then it becomes a passive act, like revenue stream, simply for the willingness to participate. And you already see this in the
Yeah.
US in some sort of programs. When I was an FPNL, like for example, there was this program where people could sign up to get, like, the grid would install a device on their air conditioner or their washing machine. And if there was about to be a blackout, they could turn off their air conditioner, all right? And they could activate these reserves. And then the user would get a 5 or 10% discount on their electricity bill every month, even though most of the months
Right.
nothing happened. So it's the same concept. It's that availability that really is the key. And
Yeah.
yeah,
Very cool.
imagine if you could just be passively.
So we talked a lot on this like podcast about managing the grid. And we're kind of like in this new era of artificial intelligence. So I was going to ask you, with all this data that we have now, and since you have this experience in managing the grid, how will AI help manage this modern energy grid that we're in?
That's a really good question. On one hand, AI is
That's true.
causing a lot of problems because all these gigantic data centers that need a lot of power and energy are being plugged in. So that's one way in which AI is not helping, if I put it that way. But I mean, obviously, it's an incredibly powerful tool. Being able to analyze and find patterns in a data set, and of course these variable resources, is quite important. I don't know if I have like a super interesting answer that no one, that other people haven't said before. I mean, the obviously AI is going to be able to analyze patterns on the grid, I'm sure, that inform the operator that something's about to happen before they realize it. I'm sure that's going to be a thing if it's not already. Actually, I know a couple of startups that are using AI precisely to like deconstruct and analyze certain patterns and be able to inform the grid that something bad is about to happen. Kind of the same concept as predictive maintenance. So like, hey, your engine is about to fail, right? Like AI is used in that sense. So digital twins, I think, is another really interesting way that AI will be used. So you'll be able to run simulations and basically have
Oh,
all of
nice.
these digital assets, right? That are you're running different scenarios and you're basically saying like what's going to happen if all of these cars plug in at the same time, for example. Will I have the capacity or not? But I don't think that's a great answer because people are doing that. We're doing that before generative AI. So I don't know. I have to think about it a bit more. But hopefully that's a good like first on the cuff out of
Awesome.
the question
Got it.
or answer. Sorry.
Is there something that really excites you over the next 10 years?
Uh well, there's a lot of things. Um, I think certainly like the whole V2G thing
Do you see
is. I
that being
think
mass adopted,
it's taking
V2G?
longer to
Do you
implement.
see it being mass
What was
adopted?
that? Yeah, I think it's just an eventuality. I mean, really, the biggest barrier has been costs. Bidirectional converters are more expensive, and the software, of course, is more complex. So right now, it's been about driving costs down, and nobody wants to pay. I mean, just to give you an idea, a unidirectional like Type 2 AC charger at home, what is that like? 500 is 800 euros typically, without installation. A bidirectional one is like
Oh, wow,
4,000.
big
So,
difference.
and if the use cases aren't there or the software isn't there, I mean, it's
Yeah,
for early adopters right now. But um, I mean, I see that quickly changing. We already see major brands already have the
yep,
bidirectional hardware on the vehicles. So an over-the-air software update will enable them to start being
yeah,
bidirectional, for example. And there's others. I mean, there's others that are already there. That there's already bidirectional cars, like you said, the Ford F-150
right.
Lightning, right? That was like the whole thing. Um, so I'm really excited about that, and I really am excited about people, yeah, kind of switching their mindset to what an EV can do. And not only that, I guess everything with mobility is going to be so interesting because I think the whole paradigm of the way we move and the way that it interacts with the power grid is going to be shifting.
Right.
Autonomous vehicles, of course, would be a huge change. And if you pair that with vehicle to grid and stuff, I mean, the possibilities become really, really interesting. I've heard all crazy sorts of of ideas like edge compute in your cars. Like you mentioned AI, right? So like imagine edge computing. Your car has so much. It has a computer inside at this point. So imagine that you're doing like edge computing for AI or whatever at the car level. Um, I don't know. I really think we're going to to see EVs as a fundamental energy
Yeah,
infrastructure rather than
I actually
transportation.
feel the same way, and I think that will just increase EV adoption as a whole. I mean, people not just seeing it as something to get them from point A to point B, but hey, in the event of an outage, this could help me. It could also maybe protect my local area from a massive outage. To me, I mean, I think EVs are super important in
And
that way.
and as I mean, look, as climate
Right.
change and the geopolitical
Costs are getting more
landscape becomes
expensive,
more
right?
volatile, right? Like
Hmm.
there's a lot of factors, right, that are going to come into play. Where I mean, nobody wants to be. I think right now the whole, not to get too political, but the whole war in Iran and Strait of Hormuz and everything, it's the biggest. I mean, you're seeing it all over the world. It's one of the biggest pushes for electric vehicle adoption around the
Yeah,
world because countries are saying this is no longer just a matter of green
energy
transition
security,
and
right?
yada yada. It's energy security. I mean, sure, we are dependent on China for a lot of our batteries. They own that supply chain. They've navigated that for decades, and now they're in a position of supremacy. Um, but once a battery or a solar panel or whatever is in your country, it's there. It's not going anywhere. You don't need. It's a resource that will be able to do what it does, um, as long as it exists. So yes, maybe supplying it, like maybe the purchasing might be bottlenecked, as far as geopolitical constraints go, but it's not a resource that you actively need, like
Right.
petroleum or gas or whatever, and you use it and it's gone, right? So I think I really think that between that and the volatility that's going to be happening from more extreme weather events. I mean, we mentioned Texas a little while ago. That was an extreme weather event. That was not. It was outside of the norm. Literal gas turbines were
Right.
freezing over, and gas wells were freezing over, and that caused a huge problem, and the grid collapsed. Right, these kinds of things are going to happen more and more. I'm from Mexico, so I mean, there's power outages there all the time. So people, I think, already are like, when is this bidirectional technology going to come here so I can have my backup power plant in my garage? So I think all these factors combined are going to make electric vehicles much more attractive. And quite frankly, the economies of scale are already there. There's no stopping the transition. The people that are putting the brakes on this, they don't understand. Like it's it's a foregone conclusion. There is no stopping this. It is going to be the reality. Internal combustion engine cars will become uncompetitive compared to EVs, even without geopolitical turmoil. The functionalities of these vehicles are going to be, you know, they're going to surpass anything that an internal combustion engine car can do. Um, and there's one more thing we haven't talked about, which
Yeah,
is
of
like air
course.
quality and noise. Right? Imagine a city where cars, like the only thing you hear is the right. There's no muffler that's incredibly loud and you have to stop having your conversation or whatever. There's no exhaust pollution that's coming out. So all of this is gonna be a factor, and I just don't think that there's any
Awesome.
stopping
Good
this.
stuff. Love that. All right. So this is like the last segment. I try to keep this last part fun. So I'm going to say like a sentence or phrase, and I just want you to give me a one sentence response on your take. Like, give me a one sentence take on it. Okay. All right.
Okay.
Software becomes more valuable than hardware in terms of energy.
Oh yeah, 100%. I think
Okay.
we're already at that
Awesome.
threshold.
People will eventually make money from their parked cars, and this will become a buying decision.
Okay, I'm gonna pause here because I don't know. I really agree with these, so I don't want to say the same thing for all of them. Is it
Oh
just
yeah, you
like
could say
agree
agree,
disagree, or
disagree,
what should
or
I be doing?
if you want to say one or two sentences about that. I mean, we kind of mentioned, kind of went over that, but I think I just want to see, do you think it will become more of a buying decision for the vehicle?
I don't know if it will be a buying decision. I think it will be certainly. It will influence it though, for sure. At some point, everyone's gonna have it, so it won't be a point of differentiation. I think at the beginning, definitely, and then at some point, it's just gonna be expected. And if you don't have it, then you know it's a sign
Okay,
of a
got
bigger
it.
problem.
All right. And the future of the grid becomes decentralized.
Oh yeah, 100%. We're already there. I mean, the vast majority of energy that's being installed across the world is distributed renewable energy. So, and most every single thing is turning electric, like cars, like electric
Yep.
heaters, heat pumps. So, 100%, we're already there. It's already a thing that grid operators are sweating
All
at
right.
night about.
Awesome. All right. Europe versus US. Who's more innovative in the energy space?
um, I have to say Europe right now. I think the US is protecting vested interests that are kind of entrenching it in old technology. So I think Europe right now is more innovative in terms of its electricity markets, in terms of the way that it's managing distributed resources.
Okay.
So I'm going to give
Awesome.
Europe the
All right.
win
And
for this
final
one.
question. Imagine it's a year 2035. What's one headline that you genuinely believe we'll see about energy or transportation?
Mm. Tether, largest virtual power plant
Awesome.
in the
Love
world.
it. Cool.
uh,
Well, I really okay.
that's what my investors want to hear.
All right, Luis, I really
uh,
appreciate you
yeah.
being on this podcast. I did want to ask you, is there anything you wanted to plug? Anything that you're working on? Well, there's
Very good
tetherev.io,
question.
right?
TetherEV.io, that's our website. Um, that's really, I mean, we're a B2B company
Okay.
for the most part, so we don't have that much customer facing stuff. Um, yeah, I don't think I have that much to plug in right now, but there'll be some exciting news coming hopefully soon.
All
So
right.
stay tuned.
Fantastic. Well, thanks again. And yeah, great having you on. Thanks for listening to Decarbonizers. If you enjoyed this episode, hit like and subscribe, and join us next time as we explore more awesome ideas driving us towards a net zero future. Thank you so much.